Now, when you're balancing chemical equation, do not touch anything here. So I know that some of you finished secondary school without knowing how to balance chemical equations. You don't have to be embarrassed about it. I used to actually be like that. So I'm just going to teach you how you can balance in chemical equation in the next 5 minutes. Now, for you to know how to balance equation, you first of all must know the oxidation state of your primary element at least. In one of my videos, I explained that for you to form a compound, you have to bring two elements together, exchange their oxidation states, and when they do this, they're going to form a compound. Now, this is for binary compound, and if you've not watched the video where I explain binary compound, please go and do so. I'm going to post the link to that video in the comments. Once you know the oxidation states of an element and your radicals, then forming equations and balancing equation is very easy. I'm just going to show you how. I'm going to use a simple kind of combination. So I have here H2SO4 plus sodium hydroxide to give these two things combining. They are called reactants. So what product will this reactant give? Now, how we know what product they would give is by doing what I've discussed in one of my videos, and of course, it's simple. So here it's hydrogen plus SO4 2 minus. Here is sodium plus OH minus. Remember that how a compound is formed is that a positive element combines with a negative radical or a negative element, or a positive radical is combining with a negative element. So either way, a positive element to a negative element, a positive element to a negative radical, which one? This is our first reactant, and this is our second reactant. So in this kind of equation, the positive part of your first reactant is going to react with the negative part of your second reactant. So for here, our positive part is hydrogen. Here, our negative part is OH. So this would react with this. What's it going to form? Hydrogen. Now, okay. So I would have started from water, but I just wanted to show you something. So we're going to start from sodium. Sodium is going to react with this radical. Now remember that when this reacts, they are going to exchange their oxidation state. And for sodium, sodium has an oxidation state of 1. In a compound, we start from the positive element or radical, then we go down to the negative. So we're going to start from sodium. So we're going to write sodium here. Now remember that in forming compound, the elements involved are going to exchange radicals, right? So this sodium is going to take the radical of SO4. So which is what? 2. So here I'm going to have 2. Then the next thing that's going to happen is that I'm going to bring this SO4 here. SO4 is going to take the radical of sodium, which is 1. So I would have written 1 here, but then I just wanted to say something. Now, when you see radicals, what are radicals? Radicals are a group of elements having a charge. Now, when you see radicals, the charge in these radicals, it's for all of the elements involved in that radical. Example, I have a radical like HCO3. Now, this minus 1 here is the charge of all of this, or it's the oxidation state of all of this. These radicals we see in chemistry, right, we treat them as a single unit. That's to say that when we see a radical like this, we assume that all of these are 1. You have to cram this. Here are just a few of the radicals that you will be needing in chemistry, or that is very important in your chemistry calculation. Now, I'm going to clean this. So why did I say that? Because if sodium is 2, now if sodium was this, and we're going to be combining it with this, 2 things will happen here. Because these two places are, these two has the same radical, they are going to cancel out. So you're just going to have this. Now, if sodium is 2, but sodium can never be 2 as oxidation state. Now, if sodium was 2, had oxidation state of 2, and combining it with SO4 had oxidation state of 2, these two will cancel out. So you should know whenever you're trying to combine two elements, or an element and a radical, and both of them are having the same oxidation state, please, those oxidation states will cancel out. A proper example would be the compound MgSO4. Now, this is magnesium tetrasulfate. Remember that magnesium is in group 2. It has an oxidation state of 2. SO4, of course, has 2 minus. So when these two combine, This would cancel out, and that's why you have this here, NgSO4. Hope you get this. Hope you get it right. So we're going to clean this and we'll continue our chemical equation balancing. So yeah, now again, I wanted to explain, if example, let's say it was aluminium. Aluminium is 3 plus combining with SO4 2 minus. What's going to happen here? Now remember the exchange of radicals. So this is going to be Al, 2 is going to come here, SO4, 3 is going to cover up for this radical. Now because we are treating this radical as a unit, I will then put a bracket, then 3 is going to come here. This 3 shows that this subscript is affecting sulfur and oxygen. I hope you get that because it's very, 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 very important. So moving on, Na plus SO4 would give you this, plus H plus OH. What's it going to give you? Now I know that you may want to say hydrogen, and this is going to take the radical of this, the way we do it, and then OH, and this will take the radical of this. But please, this is chemistry. This is hydrogen, right? The same element. So these two will combine, and what you're going to have here is 2 hydrogen and 1 oxygen, which is going to give you water. Now, what you call this kind of reaction, just in case you see it in your exam, is called the neutralization reaction. This is a reaction where an acid reacts with a base to form a salt and water. Like I said, it's called what? A neutralization reaction. Now, moving on, the next thing we want to do is to balance this equation, right? Because this is what this video is about, balancing equation. I just had to explain those things so that you don't get to misunderstand me as I go on. So let's balance this equation. Now, the first way to balance equation after bringing it this way, now we've formed our product, right? By doing that method. This acid with this base, we formed our product. Now, the next thing I want to do is to balance this equation. First way to balance equation, guys, is by observation. How? I'm going to observe the amount of elements here and see if it corresponds with the one here. And if it does not, I'm then going to look for a way I can use to balance the product and the amount of elements in the reactant. So first of all, let's see the elements here and here, and let's see what quantity they are in. Now for hydrogen, we have how many hydrogen here? 2, 3, right? We have how many sulfur here? 1. Oxygen here is 4, 5. Sodium here is 1. Now this is for our product. Then over to our, this is for our reactant. Over to our product. Sodium here is 2. Okay, sulfur here is 1. Oxygen is 5. Hydrogen is 2, right? Okay, so looking at this, sulfur, sodium and sodium, they are not balanced. Sodium is 2, sodium is 1. Oxygen and oxygen, it's balanced. Sulfur and sulfur, it's balanced. Hydrogen and hydrogen, it's not balanced. So what we are trying to balance here is sodium and hydrogen. Now look at this equation. Yeah? Which of these has both sodium and hydrogen? Now I know that, okay, this has sulfur, so I should not touch it. So the sulfur is balanced. But this has my sodium and my hydrogen. So the next thing I want to do is to assume a coefficient I can add here that would cause this to balance up with this. Now this is where your cognitive comes into work. Now looking at the sodium here is 2, sodium here is 1. I would probably assume to put 2 here. Let's see how that goes. Now when I put 2 here, sodium is balanced. Now if sodium is balanced by putting 2 here, the next thing I want to see is that these 2 here definitely affects oxygen and hydrogen. Now what am I going to do next? I'm going to see how I'm going to balance this over here to be sure that oxygen and hydrogen is also affected over here. So now how many oxygen do I have? 2, 4. So instead of 5, my oxygen now is 6. And hydrogen, instead of 3, my hydrogen now is 4. So come here, I can actually make hydrogen 4. Look at here. So I just put 2 here, and hydrogen is 4, meaning that hydrogen is now balanced. But is oxygen balanced? 2 plus 4, 6. 2 plus 4, 6. Now this equation this way is balanced. Hope you get this, right? However, if this keeps on or you've been trying this method and it's difficult for you, do not worry, I got you. And I have another method for you. Now, although this method I'm about to show you is a bit more long, but when you master it, it's going to be way faster and, of course, a better way to for you to be more accurate. The observation method does not work for you, you can use this method. Now, this one also requires you to. Now, if this is a tree, if we have three compounds in an equation, we can use X, Y, Z. But here it's four compounds, so I'm just going to call this W because I don't know what coefficient is going to be here. And I'm going to call this X, and I'm going to put an imaginary coefficient here, Y, and I'll put an imaginary coefficient here, Z. So the W, X, Y, Z are imaginary coefficients. So we're trying to find the coefficients that are supposed to be there. So this is what I'm going to do. I'm going to equate whatever is here to here. Now for hydrogen, now remember that if there was a number here, how you're going to find the total amount of an element is that you're going to multiply the subscript of that element times the coefficient binding the whole of that compound. So for here now I have my coefficient that's W. W times 2, I'm going to have 2W. Hydrogen is not done in the product. I still have hydrogen here, and the subscript is 1. Subscript are those numbers you find down here. Superscripts are those numbers you find up. Hope you get that, right? So I'm going to have my 2W. 2 times W is 2W plus 1 times X. So 2W plus X. Now look for hydrogen here. Hydrogen is not in this compound, but we can find it here. So hydrogen here is 2 times Z, which is equal to 2Z. How about sulfur? My sulfur here is 1. So 1 times W, I have my W, plus, there's no sulfur here, but there's sulfur here. So I'm going to remove this plus. Equal to, my sulfur here is 1 times Y, it's Y. So W is equal to Y. Now the next element there is oxygen. So for my oxygen, I have 4 times W plus here, oxygen is 1. 1 times X is X. So 4W plus X is equal to, now remember I'm looking for oxygen. Come here, oxygen, the subscript of oxygen here is 4. Coefficient is Y. I'm going to have 4Y plus, there's also oxygen here. So oxygen here is 1. So I'm going to have 4Y plus 1 times Z, I'm going to have Z. So the next one here we have is sodium, and sodium is the last, right? We've accounted for hydrogen, sulfur, oxygen, but we've not done that for sodium. So sodium here it's just 1. So 1 times X is X. Okay, there's no other one, so I'm just going to say equal to. Are you following? Hope this is not difficult. Now when you come here, sodium is 2. So 2 times Y, it's 2Y. Now, how do we find our coefficient using this? Now, in this method too, I'm going to assume, but why this one is a little bit not so tricky is because I'm trying little numbers like 1, 2, 3. But please, never a fraction. What I mean, do not try 1.5. Do not try 2.5, 2.2, 2.1. Do not try anything point. Ensure that the numbers you're going to be assuming, they are whole numbers, either 1, 2, 3, 4, and they should be in simple ratio. Don't go and put 1,000, right? So just stay with small numbers. So the smallest number I can think of is 1, right? So I'm just going to call Y 1. So if Y is 1, I'm going to assume that Y is 1. If Y is 1, X is equal to 2, because X is equal to 2Y. So since I assume that Y is 1, I can just put the 1 here. X is what? 2, so this is where X should be. So if I have Y and I have Z, the next I want to look is for W and I have Y, I have X, so I just want to look for W and Z. So for my W, now look at this, W is equal to Y. If W is equal to Y, Y is equal to 1, meaning that our W is also 1. I'm going to clean this and put 1. Now, the last one is Z, and of course, this will now be very easy. I can use any of the equation. Now, let's look for the simplest equation. I think this is the one. This is the simplest equation having X, Y, and Z. So my W is 1, right? My X is 2. This is equal to 2. My Z is what? Z is what I don't know, right? 2 times 1 is 2. 2 plus 2 is 4. 4 equal to 2Z. So we have here it's divide both sides by 2 to get Z. So Z is equal to 2. So here it's what? 2. Now let's see if this equation is balanced. Hydrogen here is 2 times 1, 2, plus 2, 4. Hydrogen here is 2 times 2, 4. Sulfur here is 1. Sulfur here is 1. Oxygen is 4 times 1 plus 2 is 6. Oxygen is 4 times 1 plus 2, 6. Sodium is 2. Sodium is 2 times 1, 2. Now, this is a balanced equation, and I've just shown you how you can balance your equation, either by observation or by using your simultaneous equation.